Okay, let's look at this example. We have a wood products company. They are doing plywood and paper plants in several areas in the States. In one of the plant, the company makes plywood used in residential and commercial buildings. One product should be 3 to 8 plywood. This must have a mean thickness of 0.375 inches. So this is the required mean thickness, should be this. Standard deviation for the population is known to be 0.05 inches. Before sending shipment to customers, the manager tests whether they are meeting this standard or no, 0.375. And so he selected a sample of 100 sheets, and he found that the mean of the sample is 0.378 inches. So the null hypothesis, because he's looking, the default situation, he's meeting the standard, so it's equal to 375. Or the alternative hypothesis is going to be not equal to the standard, right? Standard deviation is 0.05, the n is 100. Standard deviation is known, so we are going to use the z-test, right? Also, let's find the standard error because we're going to use it. So the standard error is going to be 0.05 divided by the square root of 100, which is basically 0.005, right? Now let's go to Minitab and do the testing. So basic statistics, one sample z-test. Summarize data. What is the sample? Size is 100. Sample mean. Sample mean is, where's the sample mean? I did not write it, so let me go back here. Sample mean 0.378, so is X bar test 0.378. Okay, 378. Standard deviation 0.05. The hypothesized mean is 0.375. Options. The confidence level is 1 minus the alpha error. The alpha we're going to assume it's 5%. Okay. So the null hypothesis is mu equals m. So the alternative hypothesis is the mean is not equal to the hypothesized mean. So everything is perfect now. So what do we have now? The z-value we got is, did I click on the, just quickly here, okay. So the z-value is 0.6, and the p-value is 0.549. By the way, if you find, let's just focus on this, because Excel, we do something else. But now, anyway, let's now put the values in. So that the p-value is 0.549, as we did before. So it's clear that the p-value is really too large, so we fail to reject the null hypothesis. So we fail to reject the null hypothesis, and we can conclude that the company does not have sufficient evidence to reject the null hypothesis, so it will ship the plywood. So we fail to reject this fact. So they are we are within the measurements, within the standards, right? We don't have any evidence that says that, oh, we have errors in the thickness or something. No, we don't have evidence to support this fact, right? To do the z critical, and the z test is 0.6, as we said. So the z critical is 0.6. It's from here, the z test, which is the standardized value of this one, right? Now let's find the X bar critical and the Z critical. Z critical is quickly, we can do it because this is the graph. Yeah, 5%. It will be divided. Look at here, P over 2, 5%. That's fine. So 5%. Now we have 1.96. Negative Z is 1.96. And to look at the decision that we have is, the Z critical 1.96, and the negative Z critical is negative 1.96. And if you compare the 0.6 with these two values, if you compare these, just a second. Oops. Sorry. Oops, what's up here? Okay. If you just compare the z-test with the two criticals, you're going to find it's 0.6. 0.6 is actually, it's not less. Listen, it's 0.6 is here. It's not greater than this value. It's not less than this value. It's not greater than this value to be in the rejection region on the right, and it's not less than negative 1.96 to be in the rejection region of the left-hand side. So that's why we failed to reject the null hypothesis. To do the last thing, which is the last stuff here. So the 0.375, standard error 0.005, options equal tails, right? So what is the X bar test? X bar test, we got 378. 378 is here. 378 is not exceeding the 3.3848, and it's not less than 0.3652. So the X bar criticals, we have 0.3848, and the X bar critical on the other side, it's 0.3652. So it's not greater than this one or less than the X bar critical on the other side, okay? So X criticals, you can tell me these two critical values. So we are not on the right-hand side. It's not greater than the first one. It's not less than the second one. It's here. So we failed to reject the X bar because we have two threshold values, two cutoff values, two critical values, okay? Test value is just one because we have one sample only. So we got to the same conclusion, okay?